Okay, we're recording. Okay, I'm going to go just check out last week's stuff first. Let's get started on that. Going to desktop. I don't need this. Get rid of that. People coming in. I can't find what I've just done. Oh, here we are. Maybe I should. Let me just go out for a second. I don't want to accidentally show everybody scores. Make sure I'm set up here. I think we're all right. Oh, yes, okay. All right then. Here we go. Right then. So I'll just take you through. Is that right? Yes, okay, isn't it? I'll just take you through this. Not showing these scores. I don't like people doing this very much, to be honest. Don't like that. But I mean, I'm going to be doing slightly different quizzes later where you won't be able to do that kind of thing. So I don't recommend it. At least try, right? Try to make sense of it yourself rather than just, getting the results and then copying it. That's a bit boring, isn't it? Anyway, I'm not particularly keen on people who do this. At the same time, I want to make it accessible as possible, make it easy to do. So I won't make a fuss yet, although I may change things. We're actually in our, I think it's the 10th class today for this second semester. So we're 2/3 of the way through. And next week there's a class, and I believe there's no class the week after. I hope not. It's Christmas Day. Is it? Yes, Christmas Day. There's no class Christmas Day, is there? I don't think I want to do a class on Christmas Day. But anyway, I've never worked on Christmas Day in my life, right? It's not that have I? Or maybe I have. I can't remember. Anyway, I'd rather not, put it that way. And I don't think, as far as I'm aware, I can't really read that timetable. I'm looking at it now. It seems to be not on. Anyway, we'll work that out later. But I don't think there's a class Christmas Day. I think there's 4 classes in January, which sounds good to me. So we will be doing like quite a lot of quiz activities during that time. And I probably won't allow you to do things like this, right? Anyway, let's just scroll through this so you can see it. Just make sure that your stuff is there. Nobody's complained about this so far, so I think everybody's okay. Yeah, so I've got no problem doing this, right? Do it twice. That's good. I like that, actually. People doing it twice, I give credit for that. But not putting your name in, don't like that. And I might do something about that in the future. Okay, let me just, people coming in. Okay. All right. Just scroll through to the end. So you can check people coming in again. Oh, sorry. Better make sure people can get in. Every time somebody comes in, stops me scrolling down. So there you go. It's doing it again. Okay. It's hard work. Somebody's got their microphone on. It's really loud, actually. Okay, I think we're all right. So I'll just finish scrolling through. Okay, so you should be able to see all that now. Just make sure that there isn't a problem. As I say, nobody has complained so far. So I think everybody's got no problem, as far as I can tell. I think everybody's who sent it, it's come through, no problem. My problem is with people do this, don't like that. Please don't do that. I'm not gonna. I mean, I could set it up so you cannot do it. Right? I could do something serious. I'd rather not. Right? I'd rather people volunteered not to do it, but we'll see. Okay, right then. So I'm going to close that, and let me just go out first. So nobody's complaining. Everybody seems to be okay. All right then. Good. All right. So let me close it. Don't need to save that. And I think everybody's okay. I got a feeling people are losing their Wi-Fi connection occasionally by the sound of it. But we got 48 people in and we are recording. So you can always check it out later. And don't forget to do the quiz. Quiz should be up now. So you should be in shape. Okay, right then. Let's go back in then and get serious. I'm going to go to, what am I going to do? I've forgotten. Oh yeah, here we are. Here's last week's stuff. 97. Okay, here we go. The magic word was intentionality. Right? And I'm going to review that a little bit today. Intentionally, yeah, I mean, that's kind of the meaning, right? You do something intentionally, right? But this is about intentionality, right? That's the actual magic word. We have our intentions and we can share those intentions. We want to do things. We have motives. We want to do things. We have a goal, things we're trying to do. And we recognize that in others, which is one of the differences, it seems, between humans and animals. And I'm going to kind of review last week's stuff, right? We're talking about animals and humans' cognition, the way they see the world, the way they think. And then I'm going to take it into kind of modern treatments of language and meaning, which I think is kind of really, I mean, I struggle to understand it. I mean, it kind of makes you, it's a puzzle, right? And I'm sure your idea about this is just as good as anybody else's, certainly as good as mine. I don't know the answers to these things, but I'm going to throw up some, I think, interesting questions. Anyway, here we go. According to Chomsky, universal grammar is a result of random mutation. Yes. Not sure. Random, not random. Yes, good. So just about everybody's got that, right? I mean, that's a good start. So Chomsky is saying that language, the appearance of language in human beings' brains or minds was very sudden. Right? Just happened all of a sudden for no reason. And I'm suggesting, look, that's a bit difficult to believe because our mouths, our voice boxes, were already perfectly evolved for speech, right? It was already perfectly evolved, so it seems like it would have happened very, gradual evolution. So if you go from, for example, a monkey evolving over time to a human being, that happens very gradually. Nobody would think, you go from one day you're a chimpanzee, the next day suddenly we're humans. Well, that would be ridiculous, right? Nobody would say that. And it seems to me similar kind of idea with language. You don't think it suddenly appears for no reason. That's a little bit, I think that's a little bit crazy, actually. But anyway, that's what Chomsky thinks. It's up to you, right? And according to Chomsky, language evolution was extremely sudden, yes. No, not that. Okay, let me just, people coming in. We've got 50 people in now. Extremely sudden, taking place less than 200,000 years ago. And in fact, less than 200,000 years ago, he says about 50,000 years ago, which is very, very recent in evolutionary terms. So, I think the idea that it's sudden is very, very difficult to believe. I don't believe it. Was extremely, you could say rapid, but not rapidly. Grammar, I'm not going to accept that. In general, cognitive linguists think that language evolution was gradual, yes. General, not really. I don't think I'll accept that. Goal, no. Grammatical, not really. That's not my point here. Language evolution was gradual, was grammatical. I get what you mean, but it's not really what I'm after there. When our human ancestors left the trees about 4 million years ago, they could not run very fast, yes. Walk very fast compared to other animals. As it's fast, I'm going to say run. Yeah, climb, that's not really the point here. Cooperate, maybe they could cooperate. Yeah. So I'm going to leave it with that. An ordinary chimpanzee running on 4 legs is much faster than the fastest ever human. Yes, on 4 legs. Good. No problem, either the number or the written. An ordinary chimpanzee running on, chimpanzees don't run on 2 legs, actually, they run on 4 legs. I think they can move on 2 legs, but they're not that fast. So running on 2 legs is relatively slow. Our human ancestors did not have big, sharp teeth, or fangs is also good. Big mouths, not really. Big, sharp claws is already in. Did not have big, sharp big, sharp fangs is okay. It seems reasonable we must have had some kind of advantage. Superiority, yes. Some kind of advantages. Some kind of advantages. Some kind of advantages. Maybe that's okay. I think I better change that. Some kind of advantages. I think it's all right, isn't it? Nothing wrong with that, is there? Okay. So 11, I think I'll take advantages as okay. Some kind of dominance over that. I don't think it's dominance necessarily. I get what you mean, domination, but I don't think that's what we're looking for here. An advantage. You can do things better than other animals, and it seems that what we could do maybe was cooperate. Perhaps our human ancestors were better at communication, cooperation, yes. Communicating, yes. Cooperating, yes. Running, probably no. I get what you mean again, because it seems that we were good at long distance running. Yeah. We evolved as good long distance runners. Hang on, do you mind if I put my fire off? Because it's boiling in here, actually. Hang on. Give me a second. I'm dying. Hang on. Give me a moment. Sorry about that. I have this big heater on. And I've also got this massive great sweater. It's boiling. I'm hot. Too hot. I'm sweating like that. Okay, sorry about that. Yes. And so it seems like maybe we were good at cooperation. That was the advantage we had. But we did develop as long distance runners. It seems we could run for long distances better than animals, hairy, furry animals, big, hairy, furry animals, particularly. We could chase after them for very long periods, and they get exhausted and drop dead. And that was probably how we hunted, it seems, many people suggest. And perhaps our human ancestors were better at using or making tools than other animals, yes. Controlling, not really. Grammar. One very big problem with Chomsky's random mutation idea is that the mouths of modern humans were perfectly evolved for human language by 200. That's a mistake. It should be 200,000. Sorry. I have to change that in a second. That should be 200,000 years ago. Yeah. But you got the idea. I think you knew that because I said it about 1,000,000 times in the class. But that's a mistake. I'll change that. Humans have evolved or developed is good. Yeah, so 200,000 years ago, certainly, right? 250,000 years ago, actually. We were modern humans, exactly the same as we are now physically. So how did that happen, right? How is it that our mouths had evolved perfectly for human language, but we had no language? Really? I mean, why did why did our mouths evolve perfectly for language then? That's a really big question, and modern mainstream linguists like Chomsky just ignore that. I mean, that's a really obvious big thing. But anyway, this is a mistake. It's not 200 years ago. It's 200,000 years ago, right? If our human ancestors were not speaking, there would have been no reason for their mouths to evolve for speech. Yes. People didn't get that. We're not evolved, not really. Yeah, trying to speak is the point. Yes, chimpanzee. Now, I think this is the whole thing. Our ancestors, like say 2 million years ago, they must have been trying to speak. It's like something, right? Making words, right? Maybe simple words, right? Maybe not putting many words together. Maybe just single words, right? But if they weren't trying to speak, then there's going to be, they're not going to evolve their speech organs and, the mouth and so on. It's just, they're going to be speaking, they're going to be cooperating. That's their advantage over animals. They've got an advantage over animals but they can communicate. They can use language to communicate. And the people who are better at speaking survive, right? If you're better at speaking, you survive. And over a long, long time, millions of years, then the speech organs develop. But if they're not speaking, then, the speech organs are not going to evolve. There's no reason to. So that's a huge, I think it's a very, very big point. It's not it's ignored by linguists. Linguists ignore it. Yeah? Chomsky totally ignores it. And recent research suggests that human brain size evolved gradually too. Yes, slowly is good, not suddenly. Yeah, people do say it's sudden, right? So I think that's, in a way, this is not a bad answer, but it's not my point here, right? And that wasn't my point in the presentation. That in fact, recent research suggests that human brain size evolved gradually. People believed there was a sudden increase in brain size relatively recently, but now the research suggests that wasn't the case. That in fact it was gradual. Brain size also developed rather gradually. Anyway, modern humans about 200,000 years ago were physically able to make all the speech sounds, yes, that we make today. And think about that, right? I mean, why? I mean, why is that true? I mean, if they didn't have speech, why would we have the ability to make speech, right? We must have been speaking, and it must have been an advantage over, for people to speak better. The better speakers survived. If you're good at speaking, you had a better chance of survival. Evolution. And humans 200,000 years ago, notice this, 200,000 years ago, had the same lips, teeth, tongue, and hard and soft palate. Yes. Plate. I don't think I'll accept it. It's palate usually. Hard plate. Do you say that? I'm not sure. I don't think I'll accept it. Palate. That's how I understand it. Palates, hard and soft palates. I see what you mean. Maybe I should accept that, actually. Palates. I suppose that makes sense. Hard and soft palates. Yeah, okay. They were anatomically, yes, be careful. Anatomically. Okay. Physically identical, yes. Spelling. Compared to other animals, human beings had bigger brains, smaller guts, they stood up straight, and they were good at long distance running. The evidence suggests, well, we're just better. We're good at long distance running. Not very good at short distances. We're very slow. But we can run down big animals over a long time. Don't know what that is. Okay. Right. Michael Tomasello says that Chomsky's theory of evolution is nonsense. Yes. Wrong. Good. Spelling. Sudden, yeah, I think that's in a way that's a good answer. It's not quite the point here, but the Chomsky's idea that suddenly comes is really difficult to believe. It's a problem, but I'm not going to give that. Tomasello says the thing that really makes humans different from animals is culture. Yes, spelling. Culture is the thing, and in culture we cooperate. Right? I mean, that's how we make culture. We cooperate to make culture. We're working together. We're understanding what we're trying to do. I understand you, you understand me. And that's what makes us different. Culture. Tomasello says that animals are very intelligent and understand why or how things happen. What things happen, not really. Recognize doesn't really work. Tomasello says that animals can understand the emotions and goals. Yes. Aim. Emotions and aim. I think I'll accept aims, but not aim. Tomasello says that the difference between us and animals is that humans have a sense of intentionality. Yes. Shared intentionality. Good. I'm going to review this again today. Shared intentionality. Now, this is a really important point, I think. This is really the big idea which shows the difference between Chomsky type linguists and the others. Shared intentionality allows us to work together. Yes. So cooperation. And we'll be dealing with pragmatics later, which is, what's that? Goyoron, right? Pragmatics, which is how we use language actually sort of in actual use. We'll be covering that later. And cooperation is the key in that. We understand that we're cooperating in some way to get a better meaning across, or maybe just have fun. But that's what it is. We're working together. Pragmatics kind of demonstrates that. In other words, we can cooperate to achieve some goal. Collaborate is good. Work together, but doesn't really work here. Share to achieve some goal doesn't quite work. At around 1 year old, 1 year old, that's weird, isn't it? 1 year old. Don't like that. I think I'll change that. Human babies start showing things to others. Yes. Start showing. Start show, you can't really say that. Start giving, not really. By contrast, chimpanzees do not point at things or show things to others. Don't look at things. They do look at things, right? But we'll mention this again today about the eyes. The eyes are different, which I think is quite important. Point at things, so they don't really point. Oh, look at that. They don't do that. And if you point, they don't really get it. Unlike animals, humans can show the direction, yes, in which they're looking. So if you look at humans' eyes, we can see, because we've got the white bit in the eyes, we can see the direction. Humans can follow eye movements, while chimpanzees only follow head movements. Yes, I'm going to review this. Yeah, not really head in this case, doesn't quite work. Even if you close your eyes and look up, a chimpanzee will also look up. Yes, we'll review this later. Even if you close your eyes and look up, chimpanzees will also look up. Like close your eyes and look up. Right? Babies won't look up, or we don't look up. We just think, what are you doing? Right? Close your eyes. If you look up with just your eyes, only your eyes, yeah, without moving your head, a chimpanzee will not look up. So a chimpanzee doesn't follow your eyes. We follow the eyes. We're sharing each other's intentions. If you close your eyes and look up, a human baby will just look at your face. Yes. Just look at your eyes. Not really, because it's closed eyes, right? So it doesn't quite work. Face spelling. Just look at your head. I guess that's right. Just look at your head. Shall I change that? 34. I don't quite like it, but I don't know. Head isn't wrong, is it? Yeah, I think it's... Yeah, maybe I should change that. Anyway, so I suppose head is okay. Kind of gets the point. If you close your eyes and look up, a human baby is just going to look at your face, just look at your head. I guess head is okay. Okay. If you open your eyes and look with just your eyes, a human baby will follow your eyes. Yes. Yes. Thomas Ellis says that humans evolve to do things together. Yes, that's right. Cooperatively. Ah. Cooperatively. 36. I think that's kind of all right. Joint or shared intention. I'm not going to set cooperative here because that's not how it's usually referred to. It's joint or shared goal. Shared attention or shared intentionality. Don't think I've given intentionality, have I? Maybe I should. Don't think that's bad. I think that's all right. Shared attention or something there. Okay, no, spelling. Human children want to play with other children, yes. Play together, the children doesn't quite work. If you point to something for you, if I point to something for you, you understand that I'm pointing at something that is useful for you, interesting for you. Yes, is it kind of okay? So you're thinking I'm pointing because I'm saying, oh, look, that's useful or that's interesting. Yeah. Need or necessary might be okay, but it's not really necessary. It's more interesting or useful. The study of language use in real situations is called pragmatics. Good, yes. And pragmatics, cooperation is really the key. Cooperative communication is the key to understanding pragmatics. Key, and that's it. Okay, then. So I think I've got a couple of things to change there. So let me just change that. We got, what was the magic word? The magic word was intentionality. That's right. That's good. So I'm going to change these so you can see it. Some kind of advantages, I think, is okay. I gave dominance. I'm not sure I like dominance, but there you go. I'll accept it. Some people did put that in. 14. Our mouths were perfectly evolved. Oh, yes, that's right. This should be 200,000 years ago. Think about that, please. I think that's an important point. Why were our mouths evolved for speech 200,000 years ago if we weren't speaking? Doesn't make sense. Palates or palates, I think, is all right. Works grammatically. And 28 is, whoops, what's happened there? It's got messed up. I hate it when it does that. 28, where is it? 28, around start showing, around 1 year old. Yeah, I see there, 1 year old, that's right. And 34 is, if you close your eyes and look up, a human baby will just look at your face or your head. I guess head is okay. It's not quite what I was looking for, but I think it's no problem with that. 36. Um, cooperative. Cooperatively is there. Okay, no problem. So that's there. And 38 shared. I'm going to accept intentionality here because that's, one of the things we talk about. That's all right. Okay, then. Good. So that's now going to show up. You'll get those points if you put those in. And just try to get into today's stuff. Today's is here. Now I'm going to... So look, the magic word today is predicate. 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 And I do a little review here, right? A little review, because I'm going to go through some of these things. And then after that, I'm going to move on to modern linguistic ideas. And kind of hopefully get you to think about this, because I find it very difficult to understand how this makes sense, right? But I want you to at least think about some of these things. Okay, then. Let me just go in here. And I'm going to just very briefly review this. I won't bother with that. I'll just mention Tomasello. So I'm just going to review this and remind you of what we were talking about. So there's Mike Tomasello. He says that culture was the most important thing in explaining what's different between humans and animals. We have culture, they don't. And it started millions of years ago. We cooperated. Because we were cooperating, we had this advantage in cooperation. This allowed us to make culture. Why are we able to do this? How does culture change individuals? And then we compare, as I said, we compare ape learning and human learning. They can see things like us and remember. They understand things. They recognize things. They understand emotions and goals. They're very intelligent. Animals are very, very intelligent. They're not stupid. What can't they do? And the difference is that we kind of understand that we are sharing our intentions. I'm trying to do something. You're trying to do something. I'm trying to do something. I know you're trying to do something. Right? We are in Zoom. I'm trying to teach a class. You're trying to get the credit. We get that, right? We understand that, and it enables us to kind of make progress, cultural progress, I suppose. So shared intentionality, that's what that is. We work together for a goal. Just going to do a very, very brief review because I want you to just go back to this, right? This idea of evolution, language evolution, and then connect that to modern linguistics. So he's showing things, right? So 1-year-olds, they say, oh, look at this. Oh, look. Oh, that's amazing. It's cool. Look at that, right? So, kids do that, right? Excuse me. They're going, oh, look at that. And like, you see the kid here, he's looking at the person he's showing it to, right? He's showing something and he's also saying, oh, look at that. And he's checking that is that person looking at it. Yeah. Now, animals are not really doing that. Yeah. So there's something there, right? And it relates to culture. It's a joint attention. We both have attention on the same thing, like we do now, I hope. I hope. Right? So we show things and check out the other person. I can't check you out. Oh, no, that's the problem here. So if we were in the classroom, right? That's funny, actually. I mean, if we were in the classroom and I'm talking like this, right, then I'm going to be talking and maybe showing you stuff on the screen, showing you all this stuff. And I'm also going to be checking you out, looking at you. Are you looking at it? And I can't do that now, right? which in some ways is bad, I suppose, but some ways it's good because, sometimes you get angry because people are falling asleep and stuff like that. Now, if you just walk off to the toilet or whatever, it doesn't bother me particularly. So maybe that's good in some ways, but you get the idea. So anyway, we're saying this is useful, right? This is going to help you. You should check this out. Maybe it's useful. It's fun, right? Think about how we use language. We're saying, oh, this is useful. This is enjoyable, right? That's kind of how we do it. It's interesting, yeah. And then chimpanzees are really intelligent. They're interested in things. They play with things, but they don't really look at others, right? They don't point. They don't show. They're a bit selfish compared to humans. And if you look at their eyes, as I said, we can see eye direction. Chimpanzees just follow the head movement. We follow eye movement. And we covered all this stuff about looking up and so on. I won't bother with that too much. So this is how we evolved. This is Mike saying we evolved to do things together. Yeah. And it happened over a very, very long period. We show where we're looking, we want to cooperate. Yeah. Chimpanzees don't do that. If you look at their eyes, there's no white in these eyes. It's difficult to see the direction in which they're looking. They're kind of more competitive, less cooperative. Now, sometimes we obviously compete as well, but sometimes we cooperate to compete. Humans are better at teamwork, it seems, and you've got this idea of shared attention. Okay, I'm not going to go through that too much. It's just a part of the way we see things. And out of that, you get an idea of fairness. We have like the notions of fairness and equality, which it seems animals maybe don't have to the same extent. That's one of Tomasello's points. So what makes us human? We see things from others' point of view, animals not so much. Now, it's not to say they don't see it at all, but we're definitely better. We definitely have an advantage in that respect. Okay. We share attention. We each have our own point of view. And we know that. That's the big difference. Children want to play together. Chimpanzees are less interested. Yeah, playing together. We do all this pointing. Animals don't really do that, right? 1-year-old babies understand pointing. 1-year-old babies understand pointing. Yeah. Whereas with gorillas and chimpanzees, you can point and they don't really get it, right? Animals just don't get that. You could say, if you wanted to, you could say dogs are different, right? Dogs are different. They do get pointing, but dogs are really part of our culture. They're really sort of focused on culture. They're trying to fit into human culture. So that's it's a good example of an exception. But that's it's like they're kind of tame, right? They're tame animals. They're fitting into human culture. Wild animals are not. Chimpanzees don't understand we're trying to help, right? They may point to say, look, just look at that, look at that. They think, what? What is he doing? Don't get it. We say there's something useful for you there, and we get it, right? Chimpanzees just don't get it. Okay. And now that relates, right, very directly to pragmatics. Okay. And we're going to kind of cover this later, actually, right, in more detail, probably after New Year. When pragmatics is language use in real situations where cooperation is generally the goal, right? It's the key, right? Cooperation is the key to pragmatics. I'm telling you something useful for you, right? That's how we understand it, right? Maybe it's not necessarily, true even, but we're kind of suggesting this is useful. It's useful for you. It's interesting for you, right? And we usually don't speak directly. That's one of the questions in the quiz. Because we're cooperating, we're kind of suggesting this is useful or this is interesting. So we usually don't speak directly. I'm trying to think of an example. My wife said, she said, did you forget to buy something? And she's not like saying, you're an idiot who forgot, right? She's just, nicely, indirectly suggesting something. And generally we know we're cooperating, trying to communicate. Can't see that. Okay. Okay. And that's it. Did you forget to do X? She doesn't say, do it now, right? Indirect. So culture or cooperation, right, probably started a very, very long time ago. And this maybe as soon as we come out of the trees, we're living on the ground, we're living in caves. Our advantage over animals was our ability to cooperate. And slowly over time, language developed as part of that. So Homo sapiens up there, you can go back to Homo erectus, probably before this, as we come out of the trees, starting to stand up straight. Probably language is kicking in somewhere around there. We don't know, of course, right? But maybe simple words somewhere along this line. And then here, our mouths are fully developed for language. So we're probably speaking along somewhere else, slowly developing simple words, simple expressions, putting words together maybe at some point around here. And over time, our mouths are changing, we're cooking, we're eating softer food, and our ability to speak gets better and better. Okay, here's some examples. 2 to 4 million years ago, see standing up, kind of standing up straight. Brains aren't very big compared to ours, but you can, maybe they're a bit hairy, we don't know, of course. But it seems that, they're kind of becoming human. They're smaller than us. They're more like apes. Right? They've got long arms, so maybe they're still in the trees more than us. And their guts are bigger. Right? They're not really standing. Maybe they're chewing. They have to chew their food more. And maybe they're not cooking so much yet. But they are walking on 2 legs. It seems like they're eating meat as well. Oops, somebody coming in. Yeah. So it's like you think about it is, oops. They're walking on 2 legs. They're, kind of the bigger guts, so I suppose, but maybe their guts are changing, right? Maybe the size of the guts are changing here. Maybe they are cooking, right? Maybe they are controlling fire. And because they're chewing less and digesting food more easily, maybe their guts can get smaller. So changing, slowly changing, eating meat 2 to 1.5 million years ago. They're using tools, we know that. Mouths are getting smaller, right? So mouth shape of the mouth is changing. Why is it changing? Well, because maybe they're cooking food, they're chewing less, spending less time chewing, and they're speaking. Right? They're starting to use simple words. So the better speakers survive. The ones who don't speak so well don't survive. So you can see these becoming human, but not quite, right? You can see this like the eyebrow there. It's not really quite human yet, modern humans yet. And they probably, you see the shape of their mouth, they're still a bit like a gorilla. So they can't make as many sounds as us, but it's changing, right? They are trying to use language. If they're not trying to use language, why would their mouths be changing? They must be trying to use language. And the better speakers are the ones who sort of survive. It must be really important. Speaking must be really important to survival. And that's because our culture was developing. And we were cooperating in culture. Culture was cooperation in a sense. Cooperation was culture and culture was cooperation. Communication. So we're making simple words and we're evolving. And eventually they become like us. Then you get modern humans, right? Starting in Africa, 250,000 years ago, maybe. And now their mouths are perfectly evolved, right? Perfectly evolved for speech. Everything they have is what we have, right? They're exactly like us. They are us. Yeah. They didn't need chimpanzee mouths. They had communities, and they didn't need chimpanzee mouths because they don't need to chew so much because they're cooking, right? They've developed these cultural tools. Their cooking probably ability now is very good, right? And they're living in communities, they're cooperating in communities, they have fire. And maybe the men are hunting more than the women. Maybe the women are in the home place, cooking, looking after the children, and maybe the women are speaking more than the men. Right? So maybe the women are kind of driving cultural change, and they're using tools. They can cook. Their food's softer. They had culture. Less time chewing and eating. More time for hunting. So they're communicating. They're speaking. And they get better and better at it. They evolved. So in other words, the better speakers survive. The ones who are not so good at speaking don't survive. Speaking, communication, cooperation is really important for survival. And that's why our mouths develop, our mouths evolve for speech. So Mike says it's a slow process, right? It's not sudden, right? It's a slow evolutionary process. Dan Everett also says it's a slow process. It's gradual, yeah? It's evolution. Evolution is a gradual process. Chomsky says it's random mutation. It happens suddenly. I just don't think that makes any sense. It's up to you. I mean, you can believe anything you want, but I mean, I find that incredibly difficult to believe. Chomsky said, "You don't know that. You don't know that. You don't know what was happening." No, we don't know, right? It was a long time ago. I wasn't there, but think about what happened. Right? We know what happened to their bodies. Right? We have their skulls. We know their mouths were changed. It's just a fact, right? But Chomsky says, no, it's all random. Language suddenly pops into the brain, and its syntax, its grammar, boing, 50,000 years ago. Only 50,000 years ago, he claims. So why were everything evolved? Our mouth was evolved for speech. Doesn't make sense. They had fire. They're doing all this stuff. They have tools. They can cook. Their food was softer. Their mouths evolved because they were eating cooked food. Right? It's softer. They don't have to chew so much. And at the same time, they're speaking more. Right? They're using fire. That's what Richard Wrangham says. Cooking helped us evolve. It gave us Homo erectus. So they've probably been cooking for at least 2 million years. And there's evidence of this, right? Evidence of cooking at least 1 million years ago. So controlling fire and cooking food. Cooking gives us more calories, less chewing, more free time. Our brains get bigger. Our jaws got smaller because we don't have to chew so much. Our guts got smaller because digestion is easier. We can walk and run better, particularly long distance running. Gradual change. And this gives us then possibility of endurance, something where we run after animals for a very, very long period. And eventually they collapse because they can't run long distances as well as us. And so, early humans were running after these animals in groups, cooperating to catch the animal and killing them with simple tools like sticks or stones when they collapse, and then carrying them back to the home where the women were probably cooking. So our mouths changed so we could speak because we were speaking. We were speaking a long time ago. And the ones who were good at speaking survived. And the ones who were not good at speaking didn't survive. So we started cooking a long time ago, at least probably 2 million years. That's what Richard Wrangham says. We get more nutrition, our brains grow, our guts got smaller, we could stand up straighter, we could run better, we could hunt better. All of these changes, better nutrition from cooking, get bigger, smaller guts, bigger brains, stand upright, good long distance runners, less chewing. We're not chewing our food so much. It's softer. We've got less time chewing. That's why our mouths changed. So our mouths changed because we're chewing. We don't have to chew so much. And because we're speaking. So as Chomsky says, forget about evolution. It's random mutation. Well, you know, our speech organs did evolve. If you look at these speech organs, this is like modern humans. Because we're making better tools. We could control fire. Yeah. We could cook. We could eat nice, soft food, right? We'd eat soft food so our mouths could change. We get better nutrition. So our brains could grow. We get cleverer and cleverer, and we're communicating more as we get cleverer. Yeah, I mean, the thing is, do you really believe, right? Do you really believe we could cooperate in hunting, yeah, which we know is true? We could cooperate in controlling fire, which we know is true. We could cooperate in tool making, which we know is true. We could cooperate in cooking, which we know must be true, but we never try to speak. I mean, that's what Chomsky's saying. He's saying that all this time when we're cooperating in these activities, we're not speaking. That's very difficult to believe. Yeah. So I think he says that speech had to wait until about 50,000 years ago. Now, I don't think that's true. That doesn't make sense. Our speech organs are already fully developed. Why? Why was it fully developed? Because we've been speaking for millions of years as we're chewing softer food because we're cooking and our mouths change over a very long period. So I think Chomsky's wrong. Yeah, brains are already fully developed. Why were our brains fully developed, right? And then we get language after that. Nah. So anyway, this is Chomsky says language ability suddenly appeared, right? Chomsky. Only 50,000 to 100,000 years ago. That's incredibly difficult to believe. By accident, yeah? By accident. After we develop modern mouths and tongues. It doesn't make sense. It doesn't make sense. This sudden idea of sudden language, syntax, grammar, suddenly 50,000, 100,000 years ago. It just doesn't make any sense. So I think Chomsky's wrong. If you believe that, it's up to you. That's the mainstream linguistics, right? Linguists believe that. Most linguists believe that. Yeah. If you want to believe that, it's up to you. You can. All right. Personally, I don't believe that. You can believe whatever you want, right? But I can't believe it. I'll be honest with you, right? I just think that's complete rubbish. Right? Complete rubbish. Doesn't make any sense at all. Language evolution was very gradual, happening over probably 4 to at least 2 million years ago. Yeah. Anyway, that's that. And I wanted to review that because I wanted to kind of put that in perspective, right? With what I'm now going to move on to, kind of modern treatments of language, and particularly the relationship between human language and machine language. Ooh, machine language. Anyway, remember Richard Montague is a very big name in semantics, the meanings in language. very famous person, and he's an American mathematician and philosopher. This is a review, so I hope you remember that. And he lived only about 41 years. He died when he was 41 years old. You remember? He was murdered in Los Angeles, right? But he was already established as a very famous, very important linguist. Why was he famous in semantics? He believed that natural human language, right? Natural human languages and artificial machine languages are basically the same. Yeah? So think about that again. He believed that natural human languages, like Japanese or English, and artificial machine languages, like computer languages, are basically the same. There's no difference. Okay, now I want you to think about that because I really struggle with this, right? I think, wow, is that true? And I really don't know, right? I don't know what to say. If you think about the evolution of language as we just have, from like gorilla type people over very long periods, cooperating, joint attention, sharing, cooperating information, slowly starting to speak. And you say that the way that natural language is developed is basically the same as human languages and artificial man-made languages like computer languages are basically the same. Think about it. I don't know if that's true. I don't know the answer to this. Very, very difficult for me to make sense of it. But think about it. Do you believe that's true? Is it true? Because that might be one of the questions in the quiz at the end in the test. Do you believe that human languages and artificial man-made languages like computer languages, computer code basically, are basically the same? Okay. Artificial man-made, you could say formal languages. What's that? For example, formal logic, right? I'll give you some examples, to give you some examples of this. So you can translate from English into formal logic, and that gives you the real meaning, right? Now we'll deal with formal logic in a second. Translate into formal logic, what does that mean? For example, Jill sees John. Yeah, you've got Jill sees John, and you have translate into formal logic, would be something like this, right? Sees Jill John. Yeah. Now it's like Jill is here the subject, John is the object. It doesn't really matter. It could be the other way around, right? And from, for computer doesn't understand what sees is, right? So, I mean, like, it could be anything really, right? But it's going to be something like some kind of formula like this. Simple. This is a simple example. That's a human language sentence. Translate into a machine language that a computer can understand is going to be something like that. Now then, propositional logic, right? This is kind of, I'm just going to just mention this. Propositional logic is like this: a P or a Q that represents a sentence. Yes, it's a very simple way of representing logic. There's no internal structure here. Yeah, sentences or propositions are represented as letters. So a P or a Q, that's a sentence. That's a sentence. Yeah, P is a sentence. Q is a sentence. And then you've got any proposition can be either true or false. True or false. Yeah? True or false, 1 or 0. Right? Any proposition can be either true or false, 1 or 0. Now, this is how, semantics, meaning, is handled in modern linguistics. So true or false, 1 or 0. Okay, I'm going to review this in the future. Don't worry. Okay? Just going to take you through this. But I want you to think about how language evolved, right? And the idea that it's basically the same as machine language. Think about it. Okay, so this is propositional logic. You just have everything is a letter, a sentence is a letter, and each of these propositions can be either true or false. Here's George Boole. Yeah, he's a famous mathematician, logician. Yeah, British mathematician, lived around there, beginning to the middle of the 19th century. George Boole, and he came up with Boolean algebra, which is binary, right? It's binary. Now it's like it's one of two things. It's binary. Yeah. In other words, we just mentioned true or false, 1 or 0, on or off. Yeah. True or false, 1 or 0, on or off is one of two states. It's two possibilities. Yeah. It's one of two possibilities. True or false, 1 or 0, same thing. On or off, same thing. It's a two-state condition. And he came up with the idea you can understand everything in terms of that. Now think about that, right? So Boolean algebra is binary. There's two states, on or off, true or false, 1 or 0. Yeah. So these are all the same thing. On, true, 1. Yeah. If it's on, it's true, it's 1. Same meaning. Off is false, 0. Same meaning. Yeah. So that's Boolean algebra. And this became rather important in the development of logic, how we think, understanding how we think. Yeah. So this is about like thinking about how we actually think. Now think about the evolution of human beings. Do we think about that? Do we think like that? Anyway, have a think about it. Let's take any sentence. John is hungry, for example, right? And we say that P equals John is hungry. P equals John is hungry. And we say P equals 1. If P equals 1, then you say John is hungry is true, right? That's true. So it's the on state. That's on, right? It's true. Okay, now it seems a bit strange. I know it seems a bit strange. Don't worry, we're going to do this again, right? So don't panic. And let's take any sentence. John is hungry, for example. P is John is hungry. If P is equals 1, that means it's true. John is hungry is true, right? Let's take any sentence. John is hungry. John is hungry, and if John is hungry is 0, that means John is hungry is false. It's not true. It's the off state, right? So, like in other words, a sentence can be either on or off. Yeah, 1 or 0, true or false. Yeah, and Boole is saying this is how we think. So then you've got not P. You have a minus, right? Minus P. If minus P equals 1, right? Minus P means not P. Not P equals 1. That means not P is true. Yeah. Okay. Don't worry too much. We're going to go through this again. So everything is either true or false. And there's three basic operations. You've got the not, right? The not operation, the and operation, and the or operation. Yeah. So it's three basic operations. This goes on one thing, right? One proposition. This takes two propositions, like P and Q, A and B, X and Z. This is or, all right? And this again takes two input, right? This takes one input. This takes two inputs. This takes two inputs. Don't worry. Don't panic. I'm just giving you this now very briefly, right? And we'll cover this again. Don't worry. So everything is either true or false. Then there's three basic operations, not, and or, right? So the not, the minus, takes one input, and takes two inputs, and or takes two inputs. So not P, right? Take P, you put the minus, the not operator on it, it says not P. P and Q, it's pretty simple really, right? You take two inputs, P and Q, you give it the and operator, it just means P and Q. P and Q is true, maybe. P or Q, again, it takes two inputs, P input and Q input, and you say it's or. Either P is true or Q is true. So anyway, why should you care, I suppose? You think, George Boole, who's he? I mean, 19th century guy, who cares? Well, modern computers make use of Boolean algebra in a very big way, all right? So if you start, I mean, many of you guys will be going from this university to work in the tech industry. Many of you will end up doing computer programming. Many of you will be working as systems engineers, for example. Yeah, systems engineers. Loads of sort of students do this. Many bunke, what's that? I don't know, arts, humanities students work in as systems engineers more than science, actually, more than BK, for example. So, you know, very many of you will be working in computers, and this is going to be kind of useful. And this is really at the heart of meaning in language, right? So I'm going to go through this. So we got propositional like. There's another operator in propositional logic. This means if, then. So if P, then Q. If P is true, then Q is true. Yeah. So like this means if P, then Q. Yeah. And you say minus if not P, then Q. If P is not true, right, then Q is true. Right? If not P, then Q. I'm just going to take you through this very briefly. Don't worry about it too much. Yeah. So if P then Q, this means if P then Q. This means if P then not Q, right? Minus. For example, John is hungry. So this is, you know, just an easy way to understand it. Let's say P equals John is hungry, and Q means John eats, right? If P then Q, if John is hungry, then John eats. Yeah. It doesn't have to be like that, right? But I mean, you know, could be anything really, but that's an easy way to understand it. P is John is hungry, Q is John eats. If John is hungry, then John eats. That's easy to understand, I think. Okay. And then, for example, John is hungry, John works, right? So let's say, for example, we say something like, make it easy to understand. We say P is John is hungry, Q is John works. This is not Q, right? Not Q. So you could say it means if John is hungry, John doesn't work. Yeah. So if John is hungry, John doesn't work. Something like that. All right. I'm just going to very briefly go through this. Don't panic. Don't panic, because I'm going to go through this again later. Right. It's just an introduction, just to start you thinking. So to remember what that is, try to remember that. If P, then Q. There's no internal structure. This is a sentence. Could be anything, but there's nothing inside it. It's just a letter. Yeah, it's just a letter. Of course, language isn't like that, right? We know that. And so then what we have is predicate logic, right? Predicate logic, magic word, predicate, magic word. Do it small letters, please. Predicate logic. Predicate logic is really like this. It means like a verb. Predicate means like a verb. It's in the quiz. And you got, for example, like this, John, Mary, for example. It doesn't have to be that. It could be Jim and Maggie. Doesn't make any difference. Could be anything, actually. Yeah. So he loves. So this could mean something like John loves Mary. Right? Could be Mary loves John. Doesn't make any difference, really. The computer doesn't know. But it does have internal structure. Right? So there's a predicate and the arguments, predicates and arguments. Okay. This might mean, for example, that John loves Mary. Okay. And then you got this, for example, here, it's not true that John loves Mary. So this is going to mean, for example, that John does not love Mary. Okay. All right. You're thinking, it's stupid. Okay. Right. I get it. All right. It does seem a bit stupid. But it could be useful for you eventually. And this is really at the root, at the heart of language, modern linguistics. Right. So you should think about it. And it may be very useful for you in the future if you're working in the tech industry, which you probably will be in one way or another. So, for example, imagine you're putting information in a computer database, right? Imagine you are inputting information into a computer, right? You're working as a systems engineer or whatever it is. You're doing computer programming. You're maybe making a website. You're doing code. You're coding on a website. You're putting information in some way. You're telling the computer something about the world, right? Now, the computer doesn't know anything. Right? The computer's stupid, doesn't know anything, doesn't know the meaning of words, doesn't know the meaning of anything, really, doesn't know the meaning of doesn't know, understand predicates, doesn't understand arguments, doesn't understand anything, right? You're just telling the computer. You have to tell the computer about everything. You're creating a world, right? Maybe it's real, maybe it's not. And the computer doesn't know, so the computer just does whatever you tell it to do. Right? The computer doesn't. The computer's not going to argue with that. Okay, and so for example, you might put something like this: Japan is a country. Right? From there, Japan is a country. For example, you want to put that information in a computer, machine language, and you say something like that. You say country X, and X is Japan. Then you say country is Japan. Yeah, in this case, Japan is a country. Yeah, you can say country X, Japan, X is Japan, country Japan. Yeah, that's one way of doing it, right? And then don't forget the computer only understands ones and zeros. Right? So all this information has to come across as either kind of ones or zeros, on or off, true or false. Everything is being communicated in those terms. The computer doesn't know what a country is, and it doesn't know what Japan is. It doesn't know anything. It just understands. It only understands on or off, one and zero. That's all. Yeah. Easy so far? Yes. But what's the point? It's a good question. Well, it helps with computer programming. All right. And we use it to input data. So in other words, it's very important in computer programming, and it's at the root of language, linguistics. All right. So we're going to do a little bit about this. Don't forget the computer's very fast, much faster than us, and has a very good memory. Yeah. So computers are great. They do things very much better than we do. So computers are very clever in some ways, but they're also kind of stupid. Okay. Computers are a tool. Yeah. But they don't really understand anything. So we have to put in the data, and we can put in any information we want. It can be useful. Can be useful, or it can be completely nonsense. We do anything we want, really. But anyway, this is it. Predicate logic. We take a simple sentence and put it in the computer. We decide a predicate, and the predicate has arguments. Okay. So Peter fell over, for example. The predicate would be something like a verb. It's going to be something like that. Fell over. Yeah. That's going to be the predicate. And then the argument. How many arguments? Think. It's going to be in the quiz. All right. Well, it's going to be one, Peter, right? So fell over, Peter. Okay. Just going to you to think about this. Don't panic, right? And then you got something like this. Jim donated $100 to the city hospital, right? Jim donated $100 to the city hospital. And you're going to think, well, what's the predicate? The predicate's probably going to be, have a think. It's probably going to be donated. How many arguments? 3. Yeah. It's going to be something like this. Those are the arguments. And it's probably going to be something like this. Donated. Jim donated $100 to the city hospital. Yeah. And you're putting that information in the computer. The computer doesn't know what that is, right? You're just telling it. And you just decide the order how you do it, right? So you can make sense of it later. And the machine helps you understand, helps you organize things, helps you remember stuff, and does calculations very quickly. But you tell the computer about the world. You tell them it's true, right? You say, this is true. Number one, it's true. It's on. Yeah. Donated X, Y, Z. You could do it like that if you want to. Yeah. You just give the information to the computer. You could say something like, Ben hates computers. And then you've got hate is going to have two arguments like that. Just think about it. Because Eddie gave up. How many, the predicate was going to be, gave up. And then the argument's going to be Eddie. Okay. Now I'm just introducing this, right? Just introducing this. You got something like Emmy is a genius. What kind of predicate have you got there? It's going to be something like that. Genius or is a genius, Emmy. Yeah. And it doesn't matter really what you do, as long as you understand what's going on and you can organize it. Right? And just forget, you can put, if you want to put other stuff in, visit Mary, Family Mart, you could have the date if you want here, right? Like an adverb if you want to, right? Do anything you want really with a predicate, but it's up to you. You tell the computer about the world. You tell the computer that this is true. So computational linguistics, a verb, subject, complement, for example. You could have hit. Hit is probably going to have how many arguments? Probably two, right? Somebody hit somebody else. John hit Bill, that sort of thing. Or Ken, yeah? Bill hit Ken, that sort of thing. And then propositional logic, if X, then Y, you'd say X, then Y. If you study hard, you'll pass the test. X is you study hard, Y, you'll pass the test. Okay. And so you basically tell the computer about the world, if X, then Y. Okay, I'm just going to introduce this very, very briefly, right? And I'm going to review that again until the end of the year, right? So you'll get this eventually. But don't panic too much, right? But we're going to cover that later. Now, let me just go back into this. Where are we here? It's not giving it to me, is it? Okay, here we go. Let me just go into today's stuff. And I've covered quite a lot of stuff today. And I'm going to do a review of this. Right? Remember, the magic word is predicate. And I'm just reviewing this here. And also, let's have a look. Yes, semantics has made a big contribution to, this is again reviewing what we did in earlier weeks. This is computer science. And I actually didn't do this. What's this? In the days before computers, most people relied on printed, this is printed tables, right? I actually cover this next week, actually. And I mentioned this before, right, in earlier classes, just to make you think about this again. The early computer, invented by Charles Babbage, was known as the difference engine, right? The difference engine. And then by the mid-20th century, ready for the first, this is digital computers. I didn't actually have time to get to this today, but I'll give you the answers here. And the word digital usually refers to the use of series of the two digits, one and it's zero, right? So there's binary. And Richard Montague said there's no difference between human language and machine language. In propositional logic, sentences are represented as letters such as P or Q. And I think I'm going to leave that there, guys. Right, I think that's good enough. I think the rest of it you can work out for yourself. You did the not and things like that, or And I'm going to get, I mean, maybe this is a bit difficult because I did a very, very brief introduction, but we'll cover this again, right? I'm trying to get you to think about this again. Okay, I've given a few sort of things. Remember, this is 0 here. John did not punch Bill. Okay, and I did this. So it should be all right. And I don't think we're going to have problems. Anyway, don't worry too much. Just do your best. Right? Do your best. As I say, we will be reviewing this a lot in the future. Anyway, guys, I'm going to give you a chance. So some people have already done it. Let's have a look how they did. Doesn't seem too bad. Not a bad score so far, I think. It should be all right. Okay, why not? Yes, you've already done it, so it can't be that difficult. But I will give you a bit of time. Yeah, I'll give you a bit of time to work through that. Let's have a look. Let's see what people are saying. Artificial language can only understand formal language for now, though. Yes. Do you have a class after this class? I have something to ask you regarding today's topic and my thesis. I'm going in this afternoon. So I'm actually home now, but I'm going in the afternoon. So I don't know if about after 2:50, about 3 o'clock. Oh, sure. Yeah, do it. I'll tell you what, I'll hang around then. Yeah, I mean, like I'll close the class down. And if you have any questions, just hang around and do it. Yeah, I mean, that's a good point, though. Artificial language can only understand formal language from now. Yes, that's right. And they don't, basically artificial, sort of computers don't understand anything, right? I mean, they just do what we tell them. And they're very fast. They're very good memories. They remember stuff. They're very useful for calculations. But machines don't really understand anything, right? And if you put that in the perspective of language evolution, then I don't know, there's lots of different questions you should ask. Anyway, I'll leave that there. I'll stop there for a moment then, guys. So if nobody has any questions, I will say goodbye. Goodbye. Good luck with the quiz. Bye-bye. Bye-bye.
Good morning, Professor.
Okay, great. Hi.
So we were talking about earlier. Oh, thank you for the time. But
No
we were
problem.
talking about earlier that human language and computer language are the same. That's what Montague said, right?
Montague, yeah, that's right.
Montague, yeah.
Yeah.
But if we think about it, like I think we're like comparing it to like what current human language, the stage of our human language right now to the stage of the current stage of AI language, right?
Yeah.
Wouldn't that be kind of bit like not fair, right? So I thought it may be true that it is the same. Like, let's say if we think about like human language at the very, very start.
Yeah.
Probably our ancestor would be just like table, or fire.
Yeah.
So that means it's like 1 and 0. This is fire. It means true.
Yeah. Right.
Right.
Yeah.
And then we think about it, like let's say Chomsky's hierarchy.
Yeah.
It says that like in the very core, it's a regular language, right? Regular.
Yeah.
And then from the outside, it's context free. So human language has been evolving to what we have right now.
Right.
Do you think that that could also be the same situation with AI? So it can basically like learn a way like how human language can evolve in the same way.
I think it's a really good
right
point.
Now, yeah, because like AI language is like very new, right? And right now we have machine learning. So that's the basic. That's like one of the essence of human like skills too. We learn stuff. That's why we have this like very complex universal like how we understand things.
Right. Yeah. I mean, I think that's, that's a really good point. Yeah.
Yeah. So, do you think like?
Oh, I mean, for me, it's like I would say if people say that, right? If you say like human language and machine language are basically the same, And I kind of like think, well, what does that mean? Right? I mean, it's like, well, I don't even, I mean, for me, it's like, I'm not even sure how to understand that proposition, right? And I suppose in a way, if you say, well, this is really a question of evolution, right? That we're talking about the human language is at a particular state of evolution, right? And machine language is also at a particular state of evolution. So I guess it depends where we are, right? But it's like Chomsky, though, is saying that language is perfect, right? Is evolved suddenly, kind of random mutation just pops into our brain in a perfect state, a perfectly evolved state, for no reason, right? Built on nothing. And it just happens to be like this perfect computational system. And then I suppose then you'd say that machine language is also a kind of looking to understand that as a kind of perfect computational system. So then they'd both be the same in that sense. I guess that's what it means. But I mean,
Right.
but then I would say, well, okay, maybe, right? But there's so much evidence that language hasn't evolved that way, right? It's a gradual cultural process, right? Based on cooperative skills, yeah, collaboration, and that, frankly, isn't what like machine language is, right? It's like, joint attention. It's like I know you understand something, you know I understand something. We're focused on the same thing to try to sort of develop our understanding of it, right? Whereas a computer, we're not really cooperating with the computer. The computer is a tool, right?
Right. Do you think like from like our ancestor, like let's say Homo sapiens or erectus, right? Do you think they kind of had that feeling that they have something that they're thinking, and like they're what you just said, like they know what the other person or like the other Homo erectus is thinking?
I think they would have. I mean, like I don't know if they would have like thought about it, but I think they would naturally be aware of that, right? They would have that awareness, and it's like, and the individuals who had that awareness, right, who were able to cooperate and able to communicate, I suppose, they were the ones who survived, right? They were the ones because it was an advantage, as an evolutionary advantage,
Right.
yeah.
Yeah.
And language evolved within that kind of context. So I guess, yeah, I mean, maybe they weren't thinking that, right? They weren't actually sort of thinking, oh, I understand that, they understand that, but they were naturally aware of it in a way that animals weren't. And I think that's, yeah, it's one big part of the reason why language evolved the way it does. But that's a really good question, because that, in a way, that helps me understand it, right? Because I'm thinking, what does that mean? I mean, I don't get it, right? If you think, how can you say that human language, which is this cultural tool, could be like this machine language, right? Which is also, I guess, a cultural tool, but it's a cultural tool to kind of communicate with computers or machines. But then machines are not really cooperating necessarily. We're not cooperating with machines. They're just using the machines as tools, right? So I don't know, I mean, like, it kind of helps me make sense of it. So I think it's a really good point.
Right. Got it.
Yeah.
Yeah, because I was like doing my thesis yesterday as well, and I have been kind of a bit stuck of it.
Right.
But yeah, because
well, yeah, I mean,
like,
I'm the same, because I mean, that to me is like, that is like, what, right? What? How do you make sense of that proposition, right? The idea that they're this basically the same, right? It's really, I mean, it's a very difficult kind of puzzle, and I struggle with that desperately. But I think in a way that's what it is. It's like, you can say, well, Chomsky is saying, right? Chomsky is making very specific claims about UG, that it kind of is evolved as a perfect system, a perfect computational system, all in one go, and it's just there. And I guess the idea would be then that logic, right? Machine language, for example, is essentially the same. It's a perfect computational system. Yeah. And then, but then you think, well, is that possible, right? Because language is at, as you said, I mean, language is at an evolutionary point, right? And human language is at the evolutionary point, and presumably machine language is evolving at the same time.
Right.
Yeah. So I think that's really a fundamental question, and I hadn't really thought about that, right? So that really kind of helps me make sense of it. But yeah, I think it's a good point.
Right. Yeah.
Yeah.
Thanks. Yeah, I mean, so so one last question. I think this is the same. Like, do you think like human language was also like ultimately at the very first was just as like formal language, and then it just became complex, and then it became natural language, at least right now.
It's like at the I suppose in a way you could say in a very simple sense that you'd have just arguments in machine language, right? Like you have like a P, right? A single atomic proposition, right? If P then Q, right? And you take P,
right?
And then I suppose you could say that human language with one word statements, I suppose, yeah, like fire or animal or something like that, just one, or maybe one gesture that would actually be a bit like those atomic kind of elements in machine language. Just the preposition. That's not the preposition. Just the predicate, right? Just the predicate or just the argument. So I suppose in that sense, it could be similar. Yeah. But then you think, well, okay, so how do things evolve from there? I suppose, and it has evolved in human language, and you think, well, how could it evolve in the future? And then you think, is it possible? Is it possible for like machine language to evolve beyond human language in that sense, right? Yeah. Could you have like, I suppose, concepts that exist in machine language which don't really exist in human language? Like maybe certain dimensions in machine language which kind of transcend human language. That would be like an interesting idea. But yes, that sounds like fun. Yeah. I would just write your ideas down if I were you. Yeah. Sounds like you got some good stuff. Yeah, don't worry too much about it. I mean, like, but I think that's a very deep fundamental issue, right? Because these evolutionary state, yeah. But it's like if you say evolutionary state, that really goes against Chomsky's ideas. Right? I think that's an important point. Yeah, because he's saying, he says explicitly,
it just happens. Right?
It just happens, and it's a perfect computational system. Yeah, it just happens. There's no evolutionary process, and there's no future evolutionary process because it's already perfect.
Right.
Yeah. So I don't know. I think you could basically explore both of those possibilities.
Right. Yeah.
Yeah.
Because
Sounds like fun.
Chomsky's idea to me is like kind of absurd. Like, like we're talking like our ancestors have like small brains and it just became bigger, right? Like right now it's compared like it's changing. Like it's not perfect. If it's perfect, then nature should be just that way forever.
Right. Exactly.
Right. Yeah. So
it's like, I mean, I think that's a very, very, very important point. He's a kind of he basically ignores evolution. He ignores the idea there is gradual change, and that there likely will be gradual change if human beings survive in the future. And I guess it means that there's gradual change in machine languages as well. I don't know how it would work, but it might be interesting to think about how that could happen. No, I think you say it is completely absurd. I mean, the idea that we suddenly get UG for no reason, fully evolved in a perfect state, right, is really completely nonsensical, I think. I mean, you wouldn't say that like physically we go like overnight from being chimpanzees to being perfectly physically evolved human beings, right? Nobody would ever say that. But he's saying that about language, basically language abilities, that it's kind of just suddenly sprang into a perfect state overnight. And that's really what, I mean, that's, and again, you might mention this. I mean, like the minimalist program, right? The minimalist program is based on the idea that language is perfect, right? It's a perfect phenomenon. And the ways that these different operations take place, right? You explain that in terms of the best possible, right? The best possible operation. For example, he's saying, you know, like you move one thing from another place because that's the best possible thing you could do. So it's all explained in terms of ideals, right?
Right.
You're saying language is a perfect computational system, and because it's a perfect computational system, you can understand what's going on in language. Now, I don't think there's a guy called Lapin. Lapin was my supervisor in the University of London. Lapin and Johnson, I think they wrote a paper about that, and saying that's not how things in the biological world work, right? I mean, we don't have perfect things in biology, right? Or in the human world because we're evolving. Right. So you don't say, "Oh, it's perfect." Why would you think it's perfect, right? And particularly, why do you think it suddenly, right? Suddenly emerged in our brains in a perfect state for no reason, right? It's a very, I mean, if you really think about it, it's an incredibly strange idea.
Right.
And I don't think people in any other field, I don't think people would take it seriously.
Right.
Yeah. But anyway, sounds good. Yeah. So minimalism, you might mention minimalism actually then.
All right. Gotcha. Yeah.
Right.
Yeah. Maybe perhaps, Chomsky is like, what is that movie again? Like, you live in a computer world.
Right. Yeah, in a way. Yeah, that's right.
Yeah. If that's the case, like we are from some civilization far away from us, then in a sense we are a tool, just like computers, that we actually had already have this language that we just don't know of because we're not aware of it. Right? Yeah.
That's a really interesting idea. I never thought about that. But it's like it's almost like we've been sort of implanted with this kind of chip or something, right? Computer chip.
Yeah, it's like the Matrix, right?
Yeah,
like,
seriously,
like the world's
right?
already
Yeah, so universal grammar is like this computer chip has been implanted into us, and then so now we're kind of in touch with these future generations because we've got this perfect computational system in our brains.
Right.
So yeah, I don't know. It's like it's really exciting idea in a way, and I suppose to explore that would be really interesting. At the end of the day, I would say that is, I don't know, it's possible. Right? It's possible we're living in the Matrix, right? We're living in the Matrix, and maybe some future civilization people just implanted us with this this ability, right? And we're not even real. Maybe we're just like sort of connected to a computer or something like that, right? Which is this
or we're just like experiment for their experiments, right?
Yeah, exactly, right? So it's it's a possibility. I mean, but at the same time, I'd say that if you look at the history of human evolution, right, that wouldn't fit anywhere, right? That idea would fit nowhere in the history of human evolution, and that's the problem with Chomsky's ideas, right?
Right.
They don't fit anywhere at all in the history of human evolution. If you look at the archaeological record, right? If you look at everything we know about human evolution, then Chomsky's ideas simply do not fit. Yeah.
Right.
So it's like, and I think you're right. The only way we could make sense of it is to think that there's something very strange going on.
Right.
Yeah. So I think it's a really interesting idea. You should definitely write it. Sounds good.
Okay,
Yeah.
gotcha. Thank you so much
Right.
for
Okay. No problem.
making
Yeah. Okay. Well, this is all good. This is all
time.
being recorded, by the way, so people can see this later. Okay.
Oh,
Good.
okay. Yeah.
Right.
Yeah, so
So,
I can also refer it later. Yeah,
okay.
that would be
Great.
great.
Excellent.
Thank you.
So, anybody else got any
All right.
questions? I don't think so. Did anybody else? No, maybe they just left their computer and gone to the toilet or something. Anyway, never mind. Okay, that's really interesting. And yeah, guys, if you're still watching this, don't worry about it too much if you didn't really understand some of that stuff. We're going to review that repeatedly over the next few weeks. So take it easy. Okay, then, guys, so see you next time. Bye-bye.